In 5.1, we had systems of equations, linear equations, and we had two equations like x plus y equals 7, and then we would have another equation like x minus y equals -1. Remember, that was a system we had back in 5.1. We had two equations in our system, and we had two variables, x and y. Well, what would be more fun than a system with two equations and two variables? That's right, three equations and three variables. So our system's getting bigger now, and we have three linear equations is what we're going to have. And we'll have three variables. Now, back when we had a system with two equations and two variables, we could graph those in a plane. We had a Cartesian coordinate system, and we could graph them as lines. But in three variables, you have to go to three space, which means a plane, okay? So each plane is intersecting here. So you have a yellow plane, blue plane, and kind of this grayish plane, and they're all intersecting at this one point, and that's the solution to the system of equations, okay? So when we have three variables and three equations. Okay, so when we have three variables, we're going to go with x, y, and z. Okay, so back when we had two equations, we would get a solution like this one was 3, 4. It was an ordered pair, right? We're used to ordered pairs. We've done that before. But now when we have a solution, we're going to have, x comma y comma z, whatever those numbers are, and this will be called an ordered triple. Okay, because there's three of them. So this is new notation. It's a little bit bigger, and we're no longer in a flat plane, but rather we're in three space, three-dimensional, where you have planes intersecting each other. So hopefully I explained that okay. By the way, these are very hard to draw. Okay, so our solutions are going to be an ordered triple, okay, an x, a y, and a z. All right, the first thing they want us to do is show that the ordered triple 1, 2, -2 is a solution of the system. So they give us a system. There are three equations, and each equation has x, y, z. There's three of them. So we take each equation separately. X plus 2y minus 3z equals 9. Now I usually put a line through my z so it doesn't look like a 2. Okay, this is saying x is -1, y is 2, and z is -2. So I'm going to plug those in. -1 plus 2 times 2 minus 3 times -2 equals 9. Now this is supposed to work because it says show that this is a solution. That ordered triple has to work for all three equations. Okay, so I get -1 plus 4 plus 6. Does that equal 9? Well, -1 and 4 is 3, and 3 plus 6 is 9. So it works for the first equation, but it has to work for all equations in the system. So now I'm going to go to the second equation. 2x minus y plus 2z has to equal -8. And I'm going to put in the ordered triple. So 2 times -1 minus 2 plus 2 times -2. Does that equal -8? Well, here I get -2 minus 2 minus 4. So -2 minus 2 is -4. -4 minus 4, does that equal -8? And yes, it does. Okay, so now we have to try the third equation and see if it works. So -x plus 3y minus 4z equals 15. So the opposite of -1 plus 3 times 2 minus 4 times -2, does that equal 15? I'm kind of running out of room. Okay, so I get 1 plus 6 plus 8. Does that equal 15? And 1 plus 6 is 7, and 7 plus 8 is 15. So sure enough, it works for all three equations, and therefore it is a solution to the system. So we showed it. Yay! Yes. Smiley face, something. Yes, we showed that it worked in all three equations. Okay, so that's what we're doing there. We're checking the solution that they gave us and seeing if it really works for the system, and it does.